is R4, which is page 893 in your textbook, if you want to follow along there. But basically, we're going to start with negative exponents. We've talked about this all year, already this year. So if it's a negative exponent, that's the same as 1 over a to the positive n. So this would be the same as 1 over 4 squared, which is 1 over 16. This here would be a negative, so this is raised to that power, not the actual negative part. Okay, so the negative stays there, and then we would say this is 1 over 4 to the second. So this gives us negative 1 over 16. Now, if I had this in parentheses, then I would take the negative down here with it. Okay, so see that difference there. Okay, number 3. This is the same as 1 over 2/5 to the positive 3. Okay, I would probably approach this a little bit differently. Actually, I would probably do it like this. Let's take them both. This would be 2 to the negative 3 over 5 to the negative 3. And it's negative on the top, it moves to the bottom to become positive. And negative on the bottom comes to the top to become positive. So this would be 125 over 8. Okay, do the same thing with variables. This would be 1 over x to the 5th. Okay, this one, the x is a 1. It's a positive exponent, so that stays. And then you'd have y to the 3rd, so it moves to the bottom to become positive. Okay, the quotient rule. Basically, when you divide these, it's the same as, think back in algebra 1, you probably remember, we kind of see what cancels out, but it's also the idea of m minus n when you divide. Okay, so you could think of it two different ways. This would be 12 times 12 times 12 times 12 times 12 divided by 12 times 12, right? So those cancel out, so you're left with 12 to the 3rd power. Okay, that's one way to think about it. The other way is to use this rule, and if it has the same base, 5 minus 2 is 3, so you'd have 12 to the 3rd. Okay. This one here, you can think of it two different ways. I kind of like to think of it as making them positive, so we're going to bring that up to the top. Okay, and then when you multiply, you add your exponents, so you have a to the 13th. Another way to think about it is this: when you divide, you subtract. So 5 minus negative 8 would be a to the 13th. 5 minus a negative 8. Okay, so either way you can think about it. However, I'm not sure how you were taught in the past, but there's two ways of doing that there. Okay, this one, what I would do is make all things positive first. So I would move this to the bottom here. Okay, and then 16 over 12 is 4/3. And then when you multiply, you add, so you have m to the 20th. Okay, the other way of doing it is that divided by that is 4/3. And then negative 9 minus 11 would be m to the negative 20th. And since it's negative, you move it to the bottom. Okay, so that's the other way to think it through. Here, just straight out dividing. There's no negative exponents or anything, so 25 over 10 would be 5/2. Okay, if you think about subtraction, it'd be r to the negative 2. If you just think about there's 7 r's on the top and 9 on the bottom, and crossing them out, there's 2 left on the bottom. And then your z's, 5 minus 1 would be 4, or cross one of them out, you'd be left with 4 on the top. Okay, so the next one here, I like to take this and distribute it through. Remember, exponent to an exponent, you multiply. So this would be 4 to the negative 2, and this would be x to the negative 10. What I like to do next is get rid of your negative exponents. So the 3 stays, the x goes to the bottom, 4 goes to the bottom, and the 10 goes to the bottom. So then you can work it out. You have 3 over 16, and then you'd have x to the 12th on the bottom. Once again here, I like to get rid of the negative exponents first. So 12 and 8 stay, the p to the 3rd stays. Okay, this p is negative, so it's going to move to the top. This q is negative, so it moves to the bottom. Okay, so we have that if making them all positive. Then we divide them. 12 divided by 8, be 3 over 2, divide a 4 out. P to the third times p squared is p to the fifth. Q times q is q squared. Okay. Number 7. Okay, this distributing through would be 3 to the negative 1, x to the negative 2, 3 to the negative 2, x to the negative 10, 3 to the negative 2, x to the negative 4. Okay, and you could do a couple different things here. You could make them all positive first, or just start simplifying, whatever. What I'm going to do is I'm just going to cancel those out because I know those are the same thing on top and bottom. Then this would be 3 to the first on the bottom, x to the second on the bottom, x to the 10th on the bottom. And since this is negative, it moves to the top to become positive. Okay, so we have 3. This would be x to the 12th. Or you can just simplify it right away. When you simplify those, cross 4 of them out on each of them. You'd be left with 8 on the bottom. Okay, so that's some ideas with review of the quotient there. Okay, some other things here. Rational exponents. Okay, we'll talk about rational exponents here a little bit. It's the same thing as the nth root of a. Okay, so we're kind of separating those out a little bit. So if you think about this, when you think about half power, I want you to kind of think in your head that is the same thing as the square root of 36. Now we don't usually put the 2 there, but the square root of 36 is 6. Okay, number 2 here, this would be, okay, so the negative stays out front. This isn't, and then we do the square root of 100. Half power is a square root, so the answer would be negative 10. This one here, the negative's out front again, so the answer is negative, and we have square root of 225. And the square root of 225 is 15, so we have negative 15. This would be the fourth root of 0. So what times itself 4 times 0? Still 0. Okay, this would be the fourth root of negative 1296. Now notice the difference here. Here I keep the negative outside, and here I kept the negative inside because it's in parentheses. Okay, so this one, there's going to be no solution. Why is that? Can you take anything to an even power, multiply something together 4 times to give you a negative number? Nope. Okay, but this one we can work out because notice we're going to keep the negative outside. Okay, and we'll have that. And if you work that out, the fourth root of this number is 6. 6 times 6 times 6 times 6. So our answer is negative 6. This one here, this would be the cubed root of negative 27. Now we couldn't take a fourth root of a negative, but we can take the third root because a negative times a negative times a negative would be a positive. Okay, so the answer would be negative 3. Okay, this would be the negative outside, and then fifth root of 32. Fifth root of 32 is 2, so we'd have negative 2. Okay. Now we also want to look at this scenario here where it's not just a 1 or 1/3 or 2/3 or whatever. This is, I'm sorry, 1/4 or 1/3 or 1/5. This is 2/3, etc. So another way to think about this is going to be n a to the 1 over n raised to the m power. Because remember, if you exponent to an exponent, you have to multiply. So if I multiply this together, I get this. So I can separate this into 125 to the 1/3 squared. Okay, and we just kind of work through this. The 1/3 power is the same as the cubed root. Okay, the cubed root of 125 is 5, so we have 5 squared, which is 25. Okay, the next one we can separate that into 32 to the 1/5 to the 7th, which would be the fifth root of 32 to the 7th power. Fifth root of 32 is 2, and 2 to the 7th is 128. Okay, this one here, the negative it's not in parentheses, so the negative stays out front. And we have 81 to the 1/2 power to the third. And hopefully you don't have to keep writing this. 1/2 power, you know, is square root, so square root of 81 would be 9. And then 9 to the third, 9 times 9 times 9, 729. And since the negative is out front, it doesn't go with that. Now the negative's on the inside, so this is a little different. So we're going to have negative 27 to the 1/3 power squared. Okay, so we have the cubed root of negative 27 squared, which would be negative 3 squared, which is 9. Okay. When we get to a negative exponent, we just kind of do what we did up at the top. We move it to the bottom. So it'll be 1 over, okay, 16 to the 1/4 cubed, which would be the 4th root of 16 cubed. And the 4th root of 16 is 2. And 2 to the 3rd power is 8. Okay. This one's negative in the parentheses, so it goes with it. So it'd be the square root, right? So I'll write it out. To the 1/2 power to the 5th. So the square root of negative 4 is not real, right? So there is no real solution to that problem right there. Okay. Yeah, so we'll just keep going here. Notice these have the same bases. They're all 27. Okay, so let's think when we multiply, we're going to add these together. So this would be 27 to the 1/3 plus 1/5 gives you 6 thirds, which is 2. Okay, just like if we had x squared times x to the third is x to the 5th, right? Okay, same sort of idea. We're adding adding there. And if you think about 27 times 27 divided by 27 times 27 times 27, we have 1 over, there'd be 127 left on the bottom. Okay, now these, they're not the same, okay, not the same bases. So we can't just combine them right away, but let's see what we can do to simplify them each individually. So this would be the 4th root of 81 to the 5th, which is the same as 3 to the 5th. This is the square root of 4 to the 3rd. Oh, that's negative 3rd, right? So we should move it to the bottom then. But square root of 4 is 2. 2 to the 3rd power is 8. Okay, so we'd have, well, I'll just put it here, 2 to the negative 3rd. Okay, and since that is negative, we'll move that one to the bottom. 3 to the 5th power is 243, and 2 to the 3rd power is 8. Okay, now you can, just let you know, with all these problems without variables, you can always check your answers in Desmos. Like you could just type this into Desmos and it'll give you the answer. Okay, but make sure you understand the ideas behind them, because now we'll get to variables, and you got to be able to do it with variables too and know the properties. Okay, so if we multiply, okay, so 6 times 2 is 12, and when we multiply we have to add exponents. So 2/3 plus 1/2. Okay, remember when you add you have to have common denominators, right? Okay, so a common denominator would be 6, that would be 4/6, that would be 3/6 for a total of 7/6. And there's nothing else we can do there, so we leave it like that. Okay, next one. With the exponents here, we're going to distribute it through to all the things in there. So this would be 3 squared, which is 9. Okay, that's a 5/6. So 5/6 squared would be 10/6, which would be 5/3. And this would be y to the 6th multiplied, 3 would be 6/4, which would be 3/2. 8 to the 2/3. Okay, so if I think about that, that'd be the cubed root of 8 squared. Cubed root of 8 is 2. 2 squared is 4, we have y to the 6 thirds, which would be 2, and m to the multiply 12 thirds, which would be 4. Okay, that is a 6 there. Okay, now if I multiply these together, that would be 36. Okay, and if I think about the m's, if I have 5 thirds, and think about, remember we said at the top there, when we divide, we can subtract our exponents. So if I take my y's, let's do the m's first, comes out. So 5 thirds minus 4, okay, gives you negative 7 thirds. And 2, so the y's, y squared minus 3 halves is y to the 1/2. Since this one was negative, we'll move it to the bottom. And there's our answer. Okay, number 19, we're going to use the distributive property and put it through. So remember, when we multiply exponents, we have to add our exponents. So 2 thirds plus 7 thirds is 9 thirds, which is 3. And then this is like a 1 out front. 1 times 2 is 2. And then multiply, add your exponents. 2 thirds plus 1 third would be 3 thirds, which is 1. Okay. And the last couple here,